Alright, we are a go on simultaneous equations by elimination. So I've got 4 different examples here for introducing you to the elimination method for solving simultaneous equations. Now, in the past, we've normally done substitution. So we've had y equals some equation with some relationship of x with x, and we've then substituted that into the other equation. And we've actually eliminated a variable that way. So we've kind of been doing simultaneous equations by elimination already. This is just more of the traditional elimination method. So what's special about the equal sign? So we have y plus x equals 5. So notice that both of these equations are written as intercept form of the straight line. Okay, and we want to eliminate one of these variables, and this is actually meant to be 4. So mistake 1. Okay, we can add and subtract anything to both sides. So we could add 2 to both sides of the equation. We can subtract 5 from both sides of that equation. We can multiply both sides of the equation by -7. We could divide both sides of the equation by 10. We can do all of these things to both sides of the equation. So what we want to do here is we want to add the same thing to both sides of this equation to get rid of that x. We want to be able to, so what could we add? We could add positive x to this side, and that would get rid of this x, but it would still give us an x on this side. So that's not going to work. Okay, here's the trick. Can we add the same thing to both sides, but those two things look slightly different? We can. We can add y plus x to this side, and we can add 4 to this side. Okay, well, I've just rewritten the whole problem down again, but if I add this whole side to this equation and this to the 5, well, I've added the same thing to both sides of this equation, haven't I? Because y plus x is equal to 4, so I'm adding the same thing to both sides. Okay, let's see what happens when I add 2y plus y, negative x plus x, there's no x's, and 5 plus 4 is 9. I've eliminated x by addition. So y equals 3. Now I need to plug that back into this equation and get x equals 1. There's my solution. Okay, so that is adding those two equations together. Okay, so the trick is that I'm adding the same thing to both sides. It's just that the same thing, y plus x, and 4, they just look kind of different. Okay, what about this one? Well, I'm going to take the second equation away from the first equation. What's 2y minus y? Y. Negative 3x, take away negative 3x, no x's. And 8, take away 13, that's negative 5. So you can see how powerful the elimination method can be. You can get straight down to a solution without much work. So I subtracted y minus 3x from this side and 13 from this side, which meant that I subtracted the same thing because they were equal to each other. Now I want to get the x value. I substitute y back in. Negative 5 minus 3x is 13. Okay, so negative 5 minus 3x is equal to 13. I'll add the 5 and divide by negative 3. So negative 6, negative 5 is my solution. Awesome, so that is an example of subtracting one equation from the other. Okay, can I add and get rid of y's? No. Can I add and get rid of x's? No, the signs are all positive. Can I subtract? No, no. So I have to do something to one of these equations before I can run the addition or subtraction. What I'm going to do is I'm going to multiply all of the second equation by 2. Now I'm allowed to do that because I'm doing the same thing to both sides. So let's just keep that first equation, 2y plus 3x equals 4. And let's just change how the second equation looks by multiplying everything by 2. Oh, there we go. Now, hopefully you can understand that it doesn't matter which equation we write first, red then green pen or green red pen. So order doesn't really matter here, does it? We're just listing our two equations. So I could actually take the second equation and subtract the first. So 2y minus 2y, no y, 4x minus 3x, 1x, and 2 minus 4, negative 2. Straight away, by just adjusting the coefficients on one equation, we get a solution. Now we want y. I've got 3 equations I could put x back into. My adjusted equation 2, my original equation 2, or my original equation 1. I'm going to put it back into this original second equation. So that y minus 4 is 1, because I've got plus 2 times negative 2. So y equals 5. So negative 2, 5 is my solution. So this one is, I'll write it down here, adjusting coefficients on one equation. And you guessed it, we're going to have to adjust the coefficients on 2 equations here. So we've got just a simple addition to cancel, or eliminate, sorry. We've got a simple subtraction to eliminate. We have to adjust one equation and then we can eliminate. And this one we're going to have to adjust both equations. So because the y's in these equations have opposite signs, addition is going to work quite nicely. So I'm going to make these y's have the same coefficients. If you wanted to, you can make the x's have the same coefficients and eliminate x. The choice becomes yours. So what I'm going to do is I'm going to take this first equation. So sometimes I label them 1 and 2. So I'm going to multiply this one by 3 and this one by 2. Now I'm just going to rewrite these equations. 9x plus 6y equals 36. Then I got 8x minus 6y equals minus 2. The reason I'm doing the y is because I like to just add stuff. So 9 and 18, 17x, and the y's are cancelling, and I have 34. So x equals 2. Now I'm going to plug this 2 back into this first equation. 6 plus 2y equals 12. 6 plus 6 is 12, so y must be 3. 2, 3 is your solution. So this one is adjusting coefficients on 2 equations. Awesome. Okay, well, without further ado, hopefully you've taken some notes down on that, or you can come back and watch these if you get stuck. But here are 8 for you to have a go at. Alright, so pause the video, give those a crack, and I will begin working my way through those now. So, what do we see here? Same sign, same sign. So no matter what, we're probably going to be adding. Now, on that last example, we can actually multiply by negatives as well if you wanted to change the sign and do addition, but it's not usually necessary. So we could make these y values the same by adjusting one equation. So we're going to have 2y minus 3x equals 13. Keep the original. And we're just going to times this one by 2. 2y minus 8x equals 18. Alright, I've got equation 1 and 2 here. I'm going to go equation 1 minus equation 2. 2y minus 2y, no y. Negative 3x, take away negative 8x, positive 5x. And 13 minus 18, negative 5. X is in negative 1, and I just want to get the y value. So I'm going to put it back into this second equation. So negative 1 into here, that is y plus 4 is 9. So y equals 5. So our solution is negative 1, 5. Cool. This equation here, I've got a couple options. I could multiply the second equation through by 5 and then add. So I've got negative 5x and 5x. But I don't really want to multiply 32 by 5 at this point. So what I'm going to have to do, well, I don't have to, but I'm going to multiply this first one by 3 instead. That's easy to multiply by 3. That's easy to multiply by 3. And 0 is very easy to multiply by 3. So I'm actually going to get the first equation as 15x plus 6y still equal to 0. And I'm going to keep the second one the same. Minus x plus 6y equals 32. Okay. I'm just going to go equation 1 minus equation 2. So 16x, 15 minus negative x. The y's are going to cancel. I'm going to be left with negative 32 because 0 minus 32. What happens quite often when students are first doing elimination method is they'll go 1 minus 2 and they'll do 15 minus negative x. They'll either muck up the sign there with their number skills not being perfect, or they'll go 15 minus negative x and then they'll switch the order and go 32 minus 0. Right, so you just got to be careful there. So x is obviously negative 2, and I might check that into this, I'll put this back into this first equation, so that negative 10 plus 2y equals 0. Negative 10 plus 10 is 0, so y is 5. Negative 2, 5. Okay, question 3. Where can we adjust? Can we make 2 become 5 or 3 become 2 or vice versa? No, we're going to have to adjust both of these equations. So I'm going to multiply this first one by 2 and this one by 3. Very similar to this one here actually, making those 6's. So multiplying by 2, 4x plus 6y equals 36. Multiplying by 3, 15x plus 6y equals 69. Nice. Now we've got the first equation, second equation, we're going to go 2 minus 1, because 15 is bigger than 4, so that's nice, and 69 is bigger than 36, so that's quite nice. So 2 minus 1, we're left with 11x equals, and we're going to have 33. So x equals 3. If x is 3, put that back in. 6 plus 3y is 18. 6 plus 12 is 18, so y must be 4. 3, 4 is our solution. Just trying to keep this video a wee bit short, so I'm going to start to skip some of those rudimentary steps at the end. Alright, this is a nice one. I've got opposite signs on the y, so I'm probably going to want to add. I just need the y values to be the same. So I'm just going to multiply that first one by 2. 8x minus 6y is 50, and 5x plus 6y is 41. I've adjusted one equation, so now I can just add those. 13x equals 91, so x must be 7. You guys probably got there a little quicker than me, knowing your 13 times tables. If x is 7, we can put this back into either equation. I might put x back into, I'm going to put it back into the second equation, so that we have 35 plus 6y is 41. 35 plus 6 is 41, so y is 1. 7, 1. Cool. Question 5. Opposite signs are on my y's, so let's make those numbers the same. Then it's just adding. We'll multiply the first one by 3. and the second one by 2. 9x plus 6y equals 9. 14x minus 6y is, well, that's a pretty tricky one to multiply by 2. 78, negative 78. Cool. Now we just have to add both of those. 9 and 14 is 23x. The y's will cancel, and we have negative 69. Nice. Now divide by 23. X is negative 3. And when we plug this back in, on the last thing I'm not going to show you the plugging back in because it's a bit time consuming and we are just checking our working. But negative 3, let's go back into the first equation. Negative 9 plus 2y equals 3. Add the 9. 2y equals 12. Y equals 6. So negative 3, 6 is the coordinate of intersection for where those two intercept versions of the straight line cross over. Okay. We're going to have to adjust both of these equations. We can't get 5 to 8 easily, and we can't get 3 and 4 to be the other number easily. I'm just going to multiply this first one by 4 and this one by 3. It's going to make both the coefficients on the y 12. So 32x plus 12y equals negative 16. 15x plus 12y equals 18. And I'm going to go and I'm going to go first one minus the second one. So 17x equals negative 34. Cool. X is then negative 2. And I'll just give you the y. 4. So negative 2, 4. Alright. The y's on this equation have opposite signs. Okay. So I'm probably going to add and cancel my y's because I like to add. So whenever there's opposite signs, that's usually the variable I'm going to cancel through addition. So I need to multiply this one by 4 and this one by 7 to make both of these 28. So 48x plus 28y is equal to 12. And 35x minus 28y equals, so if you didn't have a calculator, it's 22 times 7. It's the same as by doubling and halving, 11 by 14. And you know that, well, some of us will know that 11 times tables is 1 and 4 from the 14. 1 and 4, but then add them for that middle term. 1, 5, 4. So now we can add. So 48 and 35 is 83x, and that's going to be equal to 166. 2 80s is 160, and 2 83s is 166. X must be 2, and I'll just give you the y. It should be negative 3. Cool. Last question. All right. So it's going to be subtraction, so we could make the x's the same or the y's the same. It doesn't really matter. I'm going to multiply the first one by 7 and the second one by 2. Now, don't get confused. This isn't 4 times 7 and 53 times 2. This is just me saying what I'm multiplying everything through by. So this is going to be negative 14x plus 63y equals 28. And the next one's going to be negative 14x plus 24y equals 106. So I've got equation 1 and equation 2. I'm going to go with equation 1 minus equation 2. It's going to keep my y's positive. So negative 14 minus negative 14 is gone. And I'm going to get 63 minus 24, which is 39. And that's going to be equal to negative 78 from 28 minus 106. So y is obviously negative 2. And then I'm going to plug that back in and I get my x value of negative 11. So negative 11, negative 2 is my solution. Alright, hopefully that made a lot of sense. If not, hit me out for a question. Cheers.